Okay, derivative rules for a complex product. We could go about solving this a couple different ways. One of the ways you could do it, and it could be a way to check, in case you're wondering how to check something like this, because this is a base, okay, of a power of 4, and this is a base of power 3, we could rewrite the first one 1, 2, 3, 4 times, and then rewrite the second one 1, 2, 3 times, and then you'd have 7 different terms of the function to run through the product rule, which would make this very long. Another way you could look at this, as this is one function and this is one function, and they're multiplied together. If that would be the case, then we're looking at just an f at x, which would encompass everything, including the exponent, and a g at x, including the exponent, encompasses all of this. And think of this as just strictly a product rule with 2 functions, but when we're deriving those functions, we're going to have to put them through the power of a function rule. So it'll be a little more complex, but if you guys remember, product, derivative of a product, we do f prime x times g at x plus f at x times g prime x. So we derive the first function, multiply it by the original second one, and then vice versa. So if this is our f at x, I'm going to derive this. Well, when I go to derive it, I'm going to be using, you could call it the chain rule, or you could call it the power of a function rule. I'm going to have to bring the 4 down and keep what's originally inside of those brackets. We have a 3 up there. And then I'll need to derive what's inside those brackets, which will leave me with 2x. But that's just the f prime x. My original g at x is still 4x minus 5 cubed. Okay. Then we're going to add it to the original f at x function, which is x squared plus 3 to the power of 4. And then this is the same idea. This is an exponent. So in order to derive this chain rule or power of function rule, our 3 comes down. We leave what's originally inside to the power of 2. Then we derive what's inside, which would leave us with just the number 4. Okay. Though it looks complex, it is far easier than breaking this down into no exponents and just dealing with product rule over and over and over again. From there, I don't know why I zoomed out. I want to zoom in. Let's look and see if we can find maybe a common factor or 2. Okay? Before we go about doing any of this. Now, one way I can do this to simplify to find for a common factor, and let's take anything that is a constant term or a coefficient of just one variable and bring it to the front. And what I mean by that is the terms 4 and 2x. We're going to combine those. Remember, associative property, doesn't matter what order I multiply things in. And in the other one, well, that leaves us with the numbers 3 and 4. So I'm going to bring those to the front. This will leave us 8x, x squared plus 3 cubed times 4x minus 5 cubed, plus 3 times 4 is 12, x squared plus 3 quadratic function, so we're power of 4, times 4x minus 5 squared. Now, let's look at this. First off, 8 and 12, any common factor here? 4, okay? So we can definitely take 4 out. So we're going to take 4 out of this. Think of it like we divided this and this by 4. And then, are there any other common factors here? I'm just going to highlight what we've done. Do you guys see anything else that could be a common factor? The x squared plus 3. One of them is to the power of 3, and the other is to the power of 4. So at max, how many can I take out? 3, right? We always go to the lowest exponent. So I can now take out x squared plus 3 to the power of 3. Okay, so think of it like we're dividing that whole term by that. And again, there's still one more, our last one. 4x minus 5. 4x minus 5, 1 to the power of 2, 1 to the power of 3. We got to use the exponent, which is the lowest, 4x minus 5 squared. So that is our common factor. Think of it like we're dividing the first term by this and then the second term by this. So when we do that, 8 divided by 4, let's try to just match parts up. 8 divided by 4 is going to give us 2. The x still stays. X squared plus 3 to the power of 3, well, it's the same thing down here, so that creates a 1. I'm going to draw the 1 in just so you know we did do the division, then we'll simplify after. 4x minus 5 to the power of 3 divided by 4x minus 5 power of 2. Well, that means there'll still be 1 left, so we have 4x minus 5. Plus 12 divided by 4 is 3. And again, this to the power of 3 divided by this to the power of 4, well, that'll leave one of them left. And the other one is already to the power of 2, so that just leaves 1 in those brackets. So our simplified-ish version would be x squared plus 3 cubed times 4x minus 5 squared times 2x 4x minus 5 plus 3x squared plus 3. Okay. Looks complex, and it is a complex product. It's just keeping things in order in terms of solving this.